welcome back to the mysterious unknown. Remember to like, comment, subscribe and share this video. The #1 most searched video on Google seems to be anything surrounding the James Webb telescope. So, let us explore this $10 billion invention. NASA's James Webb Space Telescope, the agency's successor to the famous Hubble telescope, launched on December 25, 2021, is on a mission to study the earliest stars and peer back farther into the universe's past than ever before. Webb is currently at its observing spot, Lagrange Point 2, called L2. Nearly 1 million miles, 1.6 million kilometers from Earth. It is the largest and most powerful space telescope ever launched. With deployment of the mirror segments now complete, and the instruments turned on, we have begun the numerous steps required to prepare and calibrate the telescope to do its job. Said Dr. Lee Feinberg. Webb observes infrared light, aka heat, which means that to ensure that observations aren't affected by any additional warmth, the scope has to stay super cold. To keep Webb cold enough, the mission team painted its radiator, which helps to radiate heat away from the telescope and components, an ultra-black color. The researchers will now use the NIRCam data to progressively align the Webb telescope. They developed and demonstrated the algorithms using a 1/6 scale model telescope testbed. They have simulated and rehearsed the process many times and are now ready to do this with Webb. The process will take place in 7 phases over the next 3 months, culminating in a fully aligned telescope ready for instrument commissioning. The images taken by Webb during this period will not be pretty images like the new views of the universe the telescope will unveil later this summer. They strictly serve the purpose of preparing the telescope for science. To work together as a single mirror, the telescope's 18 primary mirror segments need to match each other to a fraction of a wavelength of light, approximately 50 nm. To put this in perspective, if the Webb primary mirror were the size of the United States, each segment would be the size of Texas. And the team would need to line the height of those Texas-sized segments up with each other to an accuracy of about 3.8 centimeters, which is 1.5 inches. The scientists have said that the telescope commissioning process will take much longer than previous space telescopes, because Webb's primary mirror consists of 18 individual mirror segments that need to work together as a single high-precision optical surface. The steps in the commissioning process include segment image identification, segment alignment, image stacking, coarse phasing, fine phasing, telescope alignment over instrument fields of view, iterate alignment for final correction. Batala's team will use Webb to study 11 of those in-between planets, larger than the Earth but smaller than Neptune, to learn more about how they formed and have evolved through time. Getting a basic sense of what this planetary population looks like, are they rocky, or made of gas, is the start. Much of AIM's exoplanet research enabled by Webb will be focused on that kind of basic knowledge building, giving scientists more pieces to puzzle together what the population of planets beyond our solar system looks like and if such worlds could harbor potential life. Thomas Greene, an astrophysicist at Ames who has contributed to the development of Webb's instrumentation and analysis techniques for over 20 years, is leading a study on 9 planets that are less massive and cooler than many studied by previous telescopes. His study will focus on the chemical makeup of the atmospheres surrounding those worlds, the abundances of heavier elements in their composition compared to their host stars, temperatures across each planet's surface, and more. Greene's team will be taking a close look at the spectrum of the planet, to see what kind of light it emits, which gives a view into its chemical composition. The study will focus on the planet's infrared emissions and search for signs of carbon dioxide. If there are signs an atmosphere is present, and especially carbon dioxide, then TRAPPIST-1b could have formed and evolved like the rocky planets in our own solar system that also have carbon dioxide, Venus, Earth, and Mars. Finding an atmosphere around a rocky exoplanet, the word scientists use for planets beyond our solar system, won't be easy. Their atmospheres are more compact than those of gas giants, while their smaller size means they intercept less of the star's light. So can Webb really detect life on these exoplanets? Can we find even other microbial life? This would underestimate how much humanity's worldview would change by uncovering even microscopic life on a distant planet. That's because today we know of only a single instance of biology in the entire universe. Life beyond Earth is a nice idea and has been for a long time. But once James Webb starts its reconnaissance of the heavens, that idea could become the stuff of textbooks, a scary reality.